Good afternoon, everyone. First off, thank you for having me here. Second of all, I know I'm standing between you and the break, so I'll try to keep this light and fast. So our topic today is unlocking enterprise AI at scale. You already heard a lot about what generative AI can do for you, how exactly the innovations in this space have actually been happening. Let me add a little bit of color from the perspective of Cohere on how all of this works. So for the folks here who don't know what Cohere does, let me add a couple lines of color to it. Cohere is the leading enterprise LLM provider in the world. If you're there for the keynote this morning with Lisa, one thing that she spoke of really resonated with me. She had a screen with customer service on one side. You had a customer service agent in your regular interaction with, say, an Amazon representative or something like it. And in the same breath, she also mentioned life-saving technologies. We have customers on both these sides of the aisle. We have customers that have billions of interactions with their end users on things like customer service. Quite often you have the end user speaking one language, you have the customer service agent speaking a completely different language, potentially on the other side of the world. You have the documents, the policies, the orders, transactions that the interaction needs to refer to being in a completely third language. Our models are built to make sure that all of this works really well cross-lingually from a generative AI perspective. But on the other side, with clear contrast to this very important but mundane interaction, you have things like healthcare. And so our technology is also used to do summarization of patient healthcare records. So we have physicians and doctors all the way from your internist or your general practitioners to specialists like in oncology, reading through, who previously had to read through pages and pages of patient history to really understand what was going on, even when they see the patient only once in 6 months or a year. They can now very quickly go through all of that in literally seconds with a very accurate summary. They can search within those notes if they want to go deeper and understand a particular piece more. As you can imagine, this is really critical from a life-saving or from a general humanity perspective. So we classify both of those under the use cases for enterprises because you usually see this from the lens of really large companies. And so today, I want to talk to you a little bit about what we do, what sort of models we have, what do we have in market, how we partner with AMD to take them even further, and then hopefully leave you a bit with some thoughts on what enterprises really do uniquely and why we cater to their needs in an exclusive fashion. So we have two types of models. You're very familiar with the first one, of course, generative models. We have a series called Command R. We have two models in that series. One is called Command R, the other is Command R+. R is the smaller one, about 35 billion parameters. R+ is the larger one, just over 100 billion parameters. And they do all the tasks that you're very familiar with, like summarization, very accurate summarization, being able to generate text based on the exact instructions that you provide, and so on. I'll point out that because our customers are global, it is really critical to be multilingual. So the customer service agent use case that I spoke of, if you keep extending that to global enterprises that need to work with several departments, several domains, several use cases across all of the major business languages in the world, you really need to have your model performing in a top-notch fashion across all of them. So we support all of the top 10 business languages. We support more than that. But the top 10, like English, of course, all of the major European languages, Chinese, Japanese, Korean on top of that, and even Arabic, which presents very unique challenges. But to pair with that, we also have really strong retrieval models. Two flavors in those. One is embeddings, and so we have our Embed 3 model, and also re-rank, which is a very innovative new type of model. I'll talk about that in a second. Embeddings are just numeric representations of your data. So for enterprises, one part is just being able to use the generative capabilities of models like R and R+. The second part is using those capabilities in conjunction with their own data. And this is not your run-of-the-mill consumer use case where you have a chatbot, you ask a series of questions, you get some answers. You might throw in a PDF or 10 PDFs maybe even 50 PDFs every once in a while. This is enterprise, so we're dealing with, at a minimum, tens of millions of documents or artifacts, and for our largest customers, as much as 100 billion documents. And so when you're talking of that scale, being efficient with numeric representation matters quite a lot. And once again, because these are global businesses, it matters that we support the data in several different languages. So we have various flavors available in embed, from full precision all the way down to binary embeddings, which give you almost the same quality across all of them, so that you can do semantic search really, really well. But the difference in cost going from full precision to binary is significant. It's literally several orders of magnitude. But if you have several data sources, our top customers easily have hundreds of data sources, quite often with very specialized data types and very specialized search systems already built on top of them. In those cases, they're not going to start embedding everything from scratch. And so if you already have a good search system that exists, you can just use re-rank on top. Re-rank helps you just get all of the results coming in from all of these systems. Let's say you fire off a query, you have 10 different data sources, and you have the top 5 using existing search from each of these data sources. You now have 50 documents. Which of those are the most relevant to send to your generative model for doing, say, retrieval augmented generation? Re-rank helps you do exactly that. One single line of code, and you can get the most relevant documents across the ones that you pulled from all of these different sources. And so a pretty unique model, works extremely well. And so once again, available in 100+ languages. Let's see what this actually looks like in action. So since customer support is our flavor of the day, I'm showing an example with single-step tool use. The UI is one that we've actually open sourced. You can see the settings over there using a command R+ model with a small preamble to tell the agent how it's supposed to be interacting. You see some tools over here on the right, and we're just going to use one tool in this initial example that allows you to search pending orders. What's behind is actually just running a search across a specialized order system. So let's ask a question: which customers have pending orders requiring additional verification? Very quick return. We specialize in very low latency, and so you're getting exactly what you asked for. The answers are here. Can we do more with this? You'll see the reference. I'll talk about inline citations a little bit later as well. Can we extend this and actually have multiple steps so that you can do a lot more? Let's go to the settings again. You'll see that there's additional tools available. This is a demo, so these are not real-world tools per se, but our customers have exactly this use case in many forms with actual tools behind them. And so let's see if we can do more, as in create and send email to remind customers with pending orders for verification. You'll see that it's searching the pending orders. It referenced a specific data source. And now it doesn't just give you the names, it's also giving you all of the steps. These were retrieved from documents that it was able to reference. And so no matter how many documents, we actually do really well across several different documents, no matter if the answer is at the beginning, at the end. Most models typically do much better if the answer is somewhere at the beginning or at the end. Our models search very well in the middle as well. It's typically known as a lost in the middle problem. And then with that data, it was able to just send an email, as you saw as well. Simplistic example right now with only a few steps, but our customers have significantly more complex workflows and are able to hence achieve a lot with this agentic workflow that is growing more and more in terms of adoption. As you heard already, in case it wasn't clear, we really focus on the enterprise. So what are the actual attributes that we are targeting, and why are they important? Another thing that Lisa said this morning stuck with me, which was she used the word end-to-end. This is really critical. I don't think the model and only the model is the most important thing. I think for a long time, the industry has given a lot of importance to just the models. There are a number of models now that are very good. You'll see some comparisons. I'll throw up some benchmarks as well, real-world benchmarks too. You have a number of models that are very good. We have optimized them so that you have really strong operational performance as well. But just the generative model itself is not enough. You have to have an end-to-end system. So with embed and re-rank, you get that. We already spoke of massive multilinguality. The third part, and I'm going to spend a bit more on this from here on, they're really built to scale. The example I gave about documents extends to the number of interactions as well. As a consumer, it doesn't really matter if you pay $20 or $22 for a monthly subscription. Sure, it's a small difference. Per consumer, it doesn't really matter as much. You have a few interactions a day, and the scale really isn't that much from a user perspective. But when you have users in the thousands at the very least, and the interactions go significantly higher, several orders of magnitude higher, you really, really need to make sure that your cost per interaction is absolutely the lowest. And so we build performant models that have much, much lower compute footprint. We'll talk about how AMD as a partner has been really helpful in this regard, and hence coming to a really low total cost of ownership. Along with this comes full customizability. One of the problems that we see with proprietary models as well as open models is that you don't really have access to everything in the model building phase. Since we build our models from scratch, we obviously have access to not just the end state of the model, but to all of the stages up to that as well. So we have really good fine-tuning capabilities, as you would expect. So we have self-serve fine-tuning capabilities, for example, but we also have full supervised fine-tuning processing running on top when customers need that extra ounce of performance for their particular use cases. So if you want to specialize, really get much better performance for potentially more out-of-band use cases, or something that is highly specific to your domain, your industry, you can get a lot better performance by specializing or customizing on top of our models. And this goes all the way to continuation pre-training, which requires hundreds to thousands of GPUs and can be run primarily on our side because most customers don't have that infrastructure available to really give even better performance. Again, since we build our models from scratch ourselves, we can be sure of the data provenance. So as a customer, you have a guarantee from us that we will stand behind you in terms of IP indemnification. So any claims on the data that has gone into building the model itself, you can be convinced as an enterprise, this is especially important because you want to protect yourselves in front of your users. We stand behind you in terms of the data that went into building these models. We do a lot of data procurement, private deals for getting really specialized data. We also work with our own in-house annotators to really get better at how the data, especially for highly specific use cases or newer domains, how the model actually gets better at these. And you, of course, have full control in terms of where the data is. If you're using your data for fine-tuning or even in terms of usage at runtime via RAG, the data stays completely inside your network. For the last point, in terms of deployment flexibility, let's actually see how AMD is making a difference. I want to talk a little bit about our partnership and what we've been doing with MI300X specifically, and will then extend into deployment flexibility. So first off, really happy to say that Command R and R+, we've been working with AMD right from the beginning, right since the GPU was available, to optimize our models for MI300X. They're available running at top performance. They'll be rolling out very soon to your favorite cloud provider or whatever platform you prefer to use our model on. And so by the end of the month, they should be available everywhere. A lot went into making these models operate really efficiently. And so I'm really grateful to the AMD team that worked very closely with us on this. Just as a headline, it definitely provides very efficient inference. Initially, when we started off, we were able to get it running very soon. It took on the order of days, not really a long time. So porting was really easy. Our default was TensorRT because we've been using H100s primarily so far for inference, and so we used TRT LLM. We switched to VLLM for MI300X, and porting just to get going on MI300X was actually quite easy. Optimization obviously was not the same. It definitely took a lot more concerted effort, but the end result was worth it. So we have not just the models running extremely efficiently, we were able to take advantage of specific features provided by AMD as well. The first is the large memory capacity definitely makes a big difference. Our models on the generative side are 128K in context, and we were able to give full support for that with much smaller footprint than we've been able to do so far. So in terms of tensor parallelism, MI300X allows us to get the same results, but with much smaller TP. and that translates into much lower costs, obviously, for the user. We were able to take advantage of FP8, and we'll go to the quantization results in a second, but the fact that we were able to do so well with FP8 as opposed to full precision means, again, that we can do a lot more with a lot less. So let's talk about model quantization and quality a little bit. We started off with BF16 and then went to FP8. Auto FP8, getting it running was actually pretty simple, but and the quality loss, as you can see, was very minimal. But then as we tried to get even more out of it, AMD's Quark really made a big difference. And so we were able to get even better performance on FP8 with Quark. And this has been quite exciting, I think, with the amount of investment we put into this versus what we were able to get out. We are really happy. And so really looking forward to doing more with 325X, 355X, and with FP4 and FP6 that we're going to see with those as well. This is with Command R+, and the latest flavor of it, which we released in August, hence the 0824. As a final point on the cost efficiency, you can just see the inference throughput with different tensor parallelism. And so this is, again, based on R refresh, as in the 0824 model, for a particular profile, the one that we see pretty common, 1,000 tokens and 100 tokens on the output side. And so you can see that the throughput per instance actually increases significantly, even though you actually need to do less work per GPU. So in aggregate, you actually get significantly better performance. Where can you actually use this? This is where the deployment flexibility really comes into play. We are amongst the very few proprietary model providers that have a large number of deployment options. The first, as you would expect, is our SaaS API. So we have a Cohere managed platform. The GPUs that we use on this would be transparent to you as users. You're just able to use the API, send requests, get responses. But we also run on all of the managed services on all of your favorite cloud providers. So things like Bedrock or Azure Model as a Service, which let you do things from a token per token perspective, but also SageMaker, which lets you just do things from a per instance perspective. We've usually seen that as customers scale, they prefer to have more control over their workloads and hence over their costs. And so things like SageMaker became more attractive because you have the capability to keep those GPUs running at full load. But we don't stop there. We also go all the way to virtual private cloud. And so the largest customers, who often have very large footprints in hyperscalers, will often have special deals, will have really strong rates for GPUs already with these cloud providers. And so rather than use managed services for convenience, we'll often want to run our models in the most performant manner. And so we give our entire stack in the same exact manner that it operates on our SaaS product all the way to VPC. And so you get the same feature set, but in the exact environment that you prefer. And to take it to the extreme, we do the same on completely private deployment, which can be in a colo, in your on-prem environment, all the way to completely air-gapped environments as well, which are really important in certain regulated spaces. And so the last one especially makes us work really hard in terms of optimization. So you spoke of efficiency a little bit earlier. If you look at fine-tuning as an example, normally we talk of efficiency only in terms of inference, but we also have to think it up the stack in terms of things like customization. So when you have a much smaller number of GPUs available because of constraints on the geo that you're deploying in, potentially because of the location, as in literally what is the size of the facility, what is the power consumption that you can max out on, what is the cooling capability, and so on, which can be very different from running at a hyperscaler versus running in your own facility. You really need to think of how much more you can do with a minimal number of GPUs. And so with innovations like stacked fine-tunes that we came out with almost a year ago, you can actually run several fine-tuned models on a single GPU. And so the more efficient we get with the newer GPUs, like with the MI300X, the more these features matter because you can continue to save on costs without actually lifting a finger. And all of this with all of your data sitting in every single data source. So this is just a sampling of the data sources that are supported in order to do things like retrieval augmented generation, and there's several more. We do a lot more in terms of in-depth connector optimization for several of these as well, but you can access data in a very, very large number of data sources. So what does this mean in terms of actual performance? We spoke of multilingual a bit. I just thought I would throw this up just to show the out-of-the-box multilingual performance. We'll again talk of customization a little bit further, but Command R is significantly smaller, for example, than Llama 70B, and yet has comparable or better performance. The same with R+, significantly smaller than GPT-4o, but still very much comparable in terms of multilingual performance. But it's not just in the end model performance or from a quality perspective either. In terms of cost, we try to optimize at every single layer of the stack. And so from a tokenization angle, for example, if you take a look, you see a difference across the board with us versus the competition, but you see especially large differences in certain cases. So Arabic, for example, OpenAI uses 1.7x the number of tokens that Cohere uses for the same amount of text. This translates massively into difference in cost. And again, think of this in terms of enterprise scale, matters a lot more than on the consumer side. Trust is very important with enterprises. Consumers are a lot more forgiving. If you see something that doesn't quite make sense, you'll dig a little deeper or you'll just give it up. Enterprises won't, and customers of enterprises definitely won't. They expect quality, they're paying for it, they absolutely need trusted, verified answers. So out of the box, we provide very good, very low rates of hallucination. As you can see, again, really competitive, but we go one step beyond. We have features like inline citations. So if you remember in the demo earlier, there was a pane at the right that actually showed you where the data came from. That is a default with our RAG interactions. And so anytime you actually retrieve a snippet, you have a particular data point that you're picking up from a document, you get an inline citation to that, you can click on it, so you can verify that the data that we're giving you in the answer is actually accurate. We spoke of the generative models so far. Let me go a little bit deeper into embeddings as well. This is a comparison of performance for embeddings. Not every competitor actually provides embeddings, which in itself is interesting. But for several tasks on the consumer side, you don't really need embeddings. When you're chatting with your favorite chatbot, you don't really think of embeddings at all. But enterprises really, really care about embeddings, and so it's another thing that we focus on. You'll notice that there's two distinct benchmarks there. One is just BIR for English, and the other is a specifically noisy data set. The second one matters a lot more, and we are clearly competitive on the first one too, but the second one matters a lot more in the real world because real world data is imperfect. Every single enterprise customer tells us that the data that they have is broken in so many different ways. They often don't even know how broken it is until they actually try to make sense with it with our models. And so in the past, the amount of insight, the amount of access you could actually get to the data was significantly lower. But with Gen AI, you've now been able to delve a lot deeper into your data. And so any inconsistencies, any problems become apparent much quicker. So we perform a lot better on noisy retrieval specifically, and at significantly lower vector DB storage costs. So when I was mentioning the full precision versus all the way down to binary embeddings, you can see the difference in cost over here. I mean, all of our models are very much to the left over here, so significantly lower in cost, but binary within that, even another order of magnitude lower. Again, matters a lot at scale. And last comes re-rank. So you already have very good retrieval performance using embed, but can you actually improve it even further with re-rank? So on the left, you see BM25, very standard early generation algorithm for search. If you just add re-rank on top, literally one single line of code, you get a significant boost in accuracy for your search performance. And then if you use our embeddings, if you apply re-rank on top, you'll get still better performance. That's the one that you see on the right-hand side. And again, in pretty much every language that you will use. The net result across all of these is that you get very, very good retrieval augmented generation at a very optimal cost. This is on 10K RAG prompts, very usual with our customers. You can certainly scale this up even further. Very high accuracy, very, very low cost. I'll just take a couple of examples for these based on the customers that have already made these public. Oracle, certainly a very well-known name. Big business challenge when they started out with Gen AI. How do you offer Gen AI solutions in OCI, Oracle Cloud Infrastructure, so that you can supercharge businesses? They have a lot of enterprise customers, thousands upon thousands. How do you offer them the right Gen AI solutions while being flexible and maintaining the accuracy that their own applications have been known for? You have to have enterprise-level security, customizability, and then the right user control that users have already been used to. The first thing we did with them was help them optimize the models so that they can get all of these. So the security, customizability was already a given, but to actually get the use cases really, really accurate, especially with a model that is much, much smaller, we helped them customize so that they could get the best performance out of them. And so after due diligence, after running significant number of evaluations, they selected Cohere over OpenAI and Llama to be able to run several use cases. At last count, it was over 50 new business use cases already in production with over 200 actual features as part of the largest enterprise application suites, Oracle Fusion and Oracle NetSuite, with several more in the making. And the domains are very varied. You have HR, finance, supply chain, marketing, finance, ERP as well. And then use cases across the board, article generation, summarization, pretty run-of-the-mill, but then also things like supplier recommendation, which can immediately result into savings for the customer. So on one hand, you have a boost in productivity. On the other side, you have more savings, potentially more revenue, depending on the particular use case. And so several thousand companies, over 25,000, using NetSuite and Fusion will be benefiting from these as the rollout proceeds. I'll stop with this example with Fujitsu, the latest global example. And the reason I chose this was Japanese is a particularly difficult language to optimize for because it has some highly specific expectations from a formality and honorific perspective. Fujitsu tried all of the models on the market, including ours. If you see the second line in each of the clusters there, the pink lavender line, that's the one that is the default command R performance, and then you have the rest as well. So it was pretty competitive already, but not good enough for enterprise use with Fujitsu. And so we worked with them with domain-specific data in Japanese to not just improve upon our performance, but significantly beat everything else in the market as well. This is the added boost of performance while still keeping operational performance extremely good that you can get with Cohere. And so we started off with this slide at the beginning saying Cohere is the leading enterprise LLM provider. Hopefully, with all the detail that we've gone through, you can see that it's not just that it's a leading enterprise provider. You have all of these features that really go into it that really, really matter to the enterprise. And so what you need really is a Gen AI solution partner, somebody that can understand the unique needs of the enterprise that is not distracted by non-enterprise use cases and hence can optimize with partners like AMD to really make sure that your needs are satisfied. Thank you very much.